All right, I'm going to go over this classwork with you guys just because I think there's a couple problems in here, especially towards in the second page, that aren't 100% aligned with the lesson that I taught and the notes that you guys have. All right, so I just wanted to make sure you guys were able to work through a couple of these examples on your own. All right, so this first page should be fine, right? This is exactly what I went over in class. All right, so let's look at this first one. All right, so we're going to solve each equation, and then we're going to check for extraneous solutions. All right, so remember, in these kinds of problems, I want the radical completely by itself, right? And in this case, our radical is the square root of 5p minus 14. So to get it by itself, I'm going to subtract 4 on both sides. So then I get p minus 4 is the square root of 5p minus 14. All right, and then from here, what we want to do is we want to square both sides of our equation. All right, our square root and our square are going to cancel out, and then we end up with p minus 4 squared, which is the same as p minus 4 times p minus 4. And this is going to equal 5p minus 14. Right, our radical goes away. All right, now you guys should be able to FOIL this. All right, we're just multiplying this out. We end up with p squared minus 8p plus 16. Right, if you need to write out that step, you can. All right, equals 5p minus 14. All right, now that it looks like this is a quadratic equation, so I'm going to subtract 5p on both sides and then add 14 on both sides. And then we end up with a p squared minus 13p plus 30 equals 0, and then I need factors of 30 that add to negative 13, and that's going to be a negative 10 and a negative 3. All right, so then I get p minus 10 equals 0, and then p minus 3 equals 0. So then I get p equals 10, and p equals 3. All right, so once we get these answers, we want to check and make sure that they are valid solutions. All right, so I'm going to go ahead and check over here. Plug your answers into the original, right? So I'm going to start with 10. I'm going to start with p equals 10. So I'm going to get 10 equals 4 plus the square root of 5 times 10 minus 14. And so we get 10 equals 4 plus the square root of 50 minus 14. 50 minus 14 is going to get you 36. So I get 10 equals 4 plus the square root of 36, and the square root of 36 is 6. So I get 10 equals 4 plus 6, which is 10. So I get 10 equals 10, which is true. So that means p equals 10 is a valid solution. All right, let's try the same thing for p equals 3. All right, so for p equals 3, I'm going to plug in 3 into the original equation. So I get 3 equals 4 plus the square root of 5 times 3 minus 14. And then we get 3 equals 4 plus 5 times 3 is 15. And 15 minus 14 is 1. So the square root of 1. And then the square root of 1 is just 1. So I get 3 equals 4 plus 1. So 3 equals 5, right? Which is not true. So 3 is not a valid solution. Right? So 10 is our only answer here. All right, moving on to the next one. All right, this radical is already completely by itself, so all we need to do is square both sides to get rid of that radical. All right, so square both sides, we end up with a 2x plus 3 equals x plus 2 times x plus 2. All right, and then we can FOIL this, and then we end up with a 2x plus 3 equals x squared plus 4x plus 4. All right, that's after FOILing this. And then we can get everything to one side, set it equal to 0. We can subtract 2x and subtract 3. And then we end up with an x squared plus 2x plus 1 equals 0. And then we end up with an x plus 1 and an x plus 1. All right, so thankfully here we get 2 of the exact same answer. All right, because if I do x plus 1 equals 0 and x plus 1 equals 0, then you end up with x equals negative 1 twice. All right, so I really only need to check it once just because there's one answer that shows up twice, right? So let's check and make sure that this is a valid solution. So I'm going to check x equals negative 1. And that's going to be the square root of 2 times negative 1 plus 3 equals negative 1 plus 2. All right, and then 2 times negative 1 is negative 2. And negative 2 plus 3 is the square root of 1. So I get the square root of 1 equals 1. So 1 equals 1. All right, so that means 1 is a valid solution. All right, let's move along with this one. All right, so when it looks like this, what we can do is we can immediately square both sides. Again, I just have the radical completely by itself, so this is going to get us an r squared equals 20 minus r. And then move everything to one side. So move the r, move the 20, and then we get an r squared plus r minus 20 equals 0. And then this is factorable. This becomes r plus 5 and r minus 4. All right, set each of these equal to 0, and I get r equals negative 5 and r equals 4. All right, so let's plug these into the original. If I plug in r equals negative 5, then I get negative 5 equals the square root of 20 minus negative 5. And 20 minus negative 5 is 20 plus 5, which is 25. So I get negative 5 is the square root of 25. So negative 5 is 5, right, which is not true. Now I'm going to check 4. All right, and so I get 4 equals the square root of 20 minus 4. 4 equals the square root of 16, and the square root of 16 is 4. So I get 4 equals 4. My only answer here is 4. All right. Try the exact same thing with this one. All right, square the left, square the right. My radicals and the square root cancel out. So I get an x squared equals 90 minus x. I can add x, subtract 90 on both sides. And so I end up with an x squared plus x minus 90 equals 0. And so I end up with an x plus 10 and an x minus 9 equals 0. And so I get x equals negative 10 and x equals 9. All right, let's check these answers. I'm going to first check x equals negative 10. So we get a negative 10 equals the square root of 90 minus negative 10. Minus a negative is plus, so I get negative 10 equals the square root of 100. So I get negative 10 is the square root of 100, which is 10, and that's not true. All right, so negative 10 is not a solution. All right, let's check x equals 9. I get 9 equals the square root of 90 minus 9. So I get 9 equals the square root of 81. So I get 9 equals 9, which is true. All right, so x equals 9 is our only answer here. All right, now moving along over here. I need the radical completely by itself. Right, in this case, there's a plus 1 lingering. So I'm going to subtract the 1 on both sides. And 10 minus 1 is 9, so I get 9 equals the square root of 12p plus 9. And then I can square both sides to get rid of that square root. 9 squared is 81. And on the other side, the right side, I get 12p plus 9. All right, the radical cancels out. So I'm going to solve for p, subtract 9 on both sides, and I get 72 equals 12p. Divide by 12, and I get p equals 6. All right, now let's just make sure that this is a valid solution. So I get 10 equals the square root of 12 times 6 plus 9 plus 1. So I get 10 equals the square root of 12 times 6 is 72, and 72 plus 9 is 81. So 81 plus 1. So I get 10 equals the square root of 81 is 9, and 9 plus 1 is 10. So this is a valid solution. So p equals 6 is my answer. All right. And then over here, the only difference is that now I have a fourth root. All right, when you have a fourth root, you can still do the same thing, right? Just isolate your square root, or not the square root, isolate the radical. So I'm going to add 9 on both sides, and I'm going to get the fourth root of p minus 8 equals negative 5 plus 9 is 4. All right, so I'm going to raise both sides now. Instead of squared, right, it's going to be to the power of 4. And then when you do that, this still cancels out. I get a p minus 8 equals 4 by itself 4 times, gets you 256. All right, and you can verify that off to the side if you need to. All right, 4 times 4 times 4 times 4. 4 times 4 is 16. Another 4 times 4 is 16, and then you can do 16 times 16, right, the long way, right, and you should get 256. And then we can add 8 on both sides, and I get P equals 264. All right, and then that's our answer. All right, now when we go to check this, right, we just need to be comfortable with working with higher roots, right? And that was our lesson way back, right? That was in our section, our P2D was that lesson, right? We worked with higher roots, right? So this is going to be the fourth root of 264 minus 8, minus 9 is negative 5. And so I get the fourth root of 256, right? But we just did earlier 4 times 4 times 4 times 4 is 256. So we know that the fourth root, going backwards, I can split 256 into 16 and 16, and then 4 and 4. Right, so we're just going backwards now. I know that the fourth root of 256 is going to get you 4. All right, so then we end up with 4 minus 9 equals negative 5, which is true, right? I get negative 5 is negative 5. All right, so 264 is a valid answer. And then I think that's everything on this page. All right, let's just finish up with these radicals. All right, so if I have a fifth root and a fifth root, all I have to do is get them equal to each other and then raise both sides to the power of 5. All right, and then all of our 5s cancel out, and then I get a 13 minus 2n equals n over 6. All right, getting rid of the 6 on the bottom, I can multiply both sides by 6, and then those cancel out. And then I can distribute 6 over here, and then I get 78 minus 12n equals n. And then I can add 12n on both sides. All right, and so I get 78 equals 13n. And then when you divide both sides by 13, you get n equals 6. Again, odd roots, like I mentioned in class, you don't have to check. All right, there's going to be no restrictions on those. All right, so n equals 6 is a valid answer. All right, and then over here, getting rid of whatever's in front of our radical, right? I need the radical, this part completely by itself. So I'm going to divide by whatever's in front, which is 6. Let's divide by 6 on both sides. So I get the cube root of 11x plus 4 equals 5. And then I can raise both sides to the third power. I get 11x. The cube root and the cube cancel out. 11x plus 4 equals 125. Subtract 4 on both sides, and I get 11x is 121. Divide by 11, and I get x is 11. All right? And again, odd roots, we don't have to check, right? There's no restrictions on an odd radical, right? They can equal positives, negatives, right? Anything, right? The rest of these involve fractional exponents, right? I did these in the video, but majority of the ones in the video, I think all the ones in the video, had a fractional exponent equals something with another fractional exponent, right, over a variable, right? These all equal a number, right, which it's going to be the same process, but I'll just show you there's like some strange things that happen, all right? So I just want to make sure you guys are prepared for that. All right, so at number 9, I get 4 equals, keep in mind what a fractional exponent means, right? That 3 on the bottom, if we remember, is going to become the index of our radical, right? So 1/3 as an exponent is the same as the cube root of m, right? And then hopefully we remembered that we were just doing, right, literally a couple problems ago, to get rid of that radical, all you have to do is raise to the power of that index, right? So I'm going to raise both sides to the third power. 4 to the third power is 64, and I get 64 equals m. All right? Simple as that. All right? Now you can do the same thing over here, right? Again, that number in the bottom, that 2, means it's going to be a square root. So I'm going to put that 2 up front, and this is going to be 125 equals the square root of x to the third power, right? And that 3 on top means it's an exponent of 3. So now I'm kind of going to get rid of each part of it. I want to first get rid of the exponent, and then we can get rid of the radical, right? So no matter what was underneath this exponent, right, to get rid of that exponent of 3, I'm going to have to cube root both sides. Right, so let's cube root both sides. And then I get the cube root of 125, right, is going to get you 5. And so I get 5 equals the square root of x, right? And then to get rid of that square root, all we have to do is square both sides. So then I get 5 squared is 25. I get 25 equals x. All right, and that would be your answer there. All right. You can try the exact same thing with the next few. All right, something like this. Again, this 3 on the bottom is going to go out front as the index of our radical. So I get 25 equals the cube root of 5 minus 4x, right? All to the second power. And then to get rid of that square root, of that square, we can square root. This is where it gets a little bit strange, right? Because now, hopefully, we remember when we square root, we have to have a plus minus. So I get plus minus the square root of 25, which is 5. Now notice we didn't have to do that before over here, just because it was a cube root, right? Or, I'm sorry, not over here, right? I didn't have to do it because it was a cube root, right? And cube roots can be negative. It's no plus minus, right? There's only one answer with cube roots, right? But with square roots, right, it could be positive, it could be negative after taking the square root. So that's why we need that plus minus. All right, so I get plus minus 5 equals the cube root of 5 minus 4x. And then we need to cube both sides. I would split up two equations just so that you don't confuse yourself. So I get 5 equals the cube root of 5 minus 4x. And then I have negative 5 equals the cube root of 5 minus 4x. All right. And then you can cube both sides. And then 5 to the third power is 125. Is 5 minus 4x, right? Let's just go ahead and solve this. Subtract 5 on both sides, and I get 120 equals negative 4x. And then divide by negative 4. All right, this should get us x equals negative 30. All right. We can try the same thing with the other side. Over here, I can, again, cube both sides. And then I'm going to get negative 125 equals 5 minus 4x. Subtract 5 on both sides, and I get negative 130 equals negative 4x. And then divide by negative 4 on both sides. This is going to get us, I believe both of these have a factor of 2. So I know I'm going to get 2 on the bottom. And then 130 divided by 2 is going to get you 65. So we get 2 answers here. All right. So that's the only time where it's maybe a little bit confusing, right? But we'll go over more in person, right? But I just wanted to make sure you had the work for this because I know that's something that wasn't in the notes. All right. So lastly, for this one, again, I want to get whatever has the rational exponent by itself. And then keep in mind, it's just this that we're trying to get by itself. Nothing else is attached to it. I don't see parentheses around anything, so I'm just getting this by itself. So I'm going to subtract 3 on both sides. And then I get negative 3k to the 3 halves is negative 648. Divide by negative 3. Right, because again, this negative 3 is not attached to that k. So then this is going to get you k to the 3 halves is negative 648 divided by negative 3 is a positive 216. And then I can do the same thing, right? That 2 on the bottom is going to go out front. And this is the square root of k to the third power equals 216. And then I want to get rid of these one at a time. To get rid of this cube, I can cube root. And then the cube root of 216 is 6. So then I get 6 equals the square root of k. And then to get rid of the square root of k, I would square both sides. So then I get k equals 36. All right. So hopefully that clears things up. Again, I expect you guys to work on this in class. You guys have the work here if you need if you had questions, just in case. I mean, obviously I'm not there to answer any of your questions, but hopefully this helped answer some of the potential ones that would have come up.